Going to solve unit parts 2 from Leetcode. So we have been given an m by n integer array grid. There is a robot initially located at the top left corner here, and the robot tries to move to the bottom right corner, that is grid n minus 1, n minus 1. The robot can only move either down or it can only go right at any point of time. An obstacle and space are marked as 1 and 0. A path that the robot takes cannot include any square that is an obstacle, so it will not move from a square where one is placed. Return, we have to return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than 2 to the power 20 to the power 9. Okay, so we have been given a 2D vector array and we have to return the total number of paths that can be possible. So straight away looking at this problem, it came to my mind that we have to start from the top left corner and we have to reach the bottom right corner. So we have to do recursive. We have to move recursive. So the first thing that I will do is write one helper function. From where I need to start? I need to start from top, ith and the jth column. As of now, what I need to pass is grid. I will not any other function other than grid because I'm not aware of it. Okay, so whatever the answer it would, uh, okay, what I will do is I will also create one answer variable. I will also pass that answer there. Okay, I will return that answer. So whenever while iterating into this recursively in helper, whenever I reach this, I will just implement this. Okay, now let me just write the function definition of the helper. So it is not returning anything. I would make it 0 in the type of my j are the ith row and j column with 2D vector. I take it as it is, pass the reference and the answer. I want to update the answer, hence I will take it pass by reference. So this is my recursive function, right? So what I will do is here would be some base cases. Okay. What else? Now the recursive logic remains here. What I need to do is at any point of time, I have two options. Either move to the bottom right corner. Okay. So what I would do is I will have to. Okay. So what happens if I go bottom? So I plus one, correct? And J would be the same because I'm moving down. Okay. And down or right. Okay. Yes. So here I would always I would need to pass the grid. I would pass the answer. I would now if I want to move to the right, I remains as it is G plus one grid and answer. Okay. And at the end I would just return in okay. It's a void function. Okay. Now what would be my base cases? I'm incrementing I plus one, right? So if first of all, uh, I want to reach at this point, right? If I exactly equals to, I want to calculate the m and the n. M and n is nothing but the grid size. So it would be grid dot size, and this would be grid of 0 dot size. Okay. Since I'm accessing grid of 0, there it means I need to verify the constant. If there is a single row. No, we have one by one is possible, right? Yeah, then this would not go out of bound. That is fine. Now I need to check if I reach to the correct destination. Okay. if I exactly equals to n minus 1 and g exactly equals to n minus 1. At that point, what we need to do is we need to return. No, we don't need to return anything. We just need to answer plus plus. Okay. No, what are the other base cases? Uh, Out of bound cases. In out of bound cases, I'm increasing I plus 1, right? So it might be possible I can run out of the rows. So if I exactly equals to n, okay? So I exactly equals to n, at that time, I just need to return. Uh, what are the other cases? I also need to return uh, if or g exactly equals to n. So it might be possible that I would exhaust the J that is the column because I'm also implementing the J, right? So yeah, if any one out of these is reached, then I would need to return. Okay. Mm, what else? We are passing with zero. This is pure recursive solution. Okay. Uh, can we try and check? Oh, another condition is we have to only move uh, if the path is does not contain an obstacle. Okay, so how can we add that condition? Mm, we have this grid. Okay, here I can only move to right down if there is um, a valid space or no obstacle is present. So I would need to write a grid of uh, I plus 1 comma j exact equals to 0. Then only I would need to call this. Similarly, if grid of I comma g plus exactly equals to 0, then uh, I choose 1, then only I would need to go down. Okay, else we don't need to. I think so. Shall we just try and execute this now? Okay, let's try. So again, this is pure recursive. This would not get accepted provided this is an runtime. Okay, what is the error? Mm, mm, so we move down, grid I plus 1 of G is 0, then only I need to represent G grid answer. If I'm if grid G plus 1 is equal to 0, I G plus 1. Okay, here I do not have this condition, right? So my G, if G is G plus 1 is less than what? N and okay. Mm, or else, yeah, here if I plus 1 is less than M and only. Okay, let's check now. Okay, in expected 0, 1, 0, 0. Expected is 1, my output is within 3. What is the issue? Or is what we can do is instead of adding this condition here, let's change the approach. Okay. Uh, let's remove this altogether. We will add a condition here on that. Okay. Uh, if I if 3 of I of 3 exactly is to 1, I will just return from here because we don't want to move forward, right? Yeah, I think this should work. Let me check. 3, 5, 2, 2. Okay. What is happening? If speed of IoT, I have the bound cases. Mm, so if it is 2 minus 1 and minus 1, the file check exactly goes to 1, it will return 0 and move down. Mm, logic plus 1. Just issue. Yeah, it's initially it should be 0, right? Because if it did not happen anything, it would just pass any random value. Let me just try and submit. It would not get submit as this is recursive and not optimized. We can definitely optimize this approach. Oh, we are still having wrong answer. Let me put the test case. It is feeding from 0001. Okay. Oh, okay. So in this case, remove the middle of the three. There is robot input that the robot has to move to the bottom right corner. That is, the robot can only move up down or at any point of time when obstacle and space are marked with 1 and 0 respectively. The path that the robot takes cannot include any space that is an obstacle. Return the minimum number, even the number of possible unique paths. It is bottom right corner. Mm, okay. So, as per this output, it means even if the destination is at the if there's obstacle at the destination, we don't want to count. Okay, we then the only thing that we need to do is we just need to um, add this at the top. Okay, because this would return first, and then the rest of the conditions needs to be checked. Okay, let's try it one more time. Mm, Missing an address type. Okay. I would need to ensure the conditions here it is not out of bound and then this let's try now. Mm, okay, no, I'm sorry, I don't want to do this. I want to resolve it, right? I would initially want, okay, first my output ranges output bound cases, then check obstacle. So this sequence of recursive base case, is very crucial in recursion, and then the final destination chip. Okay, let's try running one more time. Yes, hopefully now it should get, now at this point it should get tab limit exceeded because it is not optimized on. Yes, here it is time limit exceeded. So now since this is recursive, in order to make it DP problem solution, we want to solve it using memoization. For making this recursion into memoization, what I need to do is I need to check. I need to initially pass a 2D uh, DP array, wherein the size would be. Now I need to calculate this here because okay. So now we need to initialize. What we need to initialize? We need to initialize with m comma uh, m cross n size. So it would be of int n and uh, sorry, initially set to -1. Declare dp array. And you might ask why this 2D, because it's a 2D grid at first, and then the variable changing parameters are 2. So I and j. So I would need 2 cross n cross n cross n. Okay. Now let us need to propagate this everywhere. I will first take it as input vector of int, vector of int, ampersand dp. Okay. So these are all base cases. So yeah, I will need to store dp of I slash j exactly equals to so uh, I want to take it as down and take the output from those functions down and right. Okay. And yeah, down plus right. Okay. Now I don't need this answer anymore. Instead, I will pass the BP. I would remove this answer. I would pass the BP. Yeah. So now earlier I was returning uh, just right. So I would need to pass zero wave out of that way. And here I will return the answer +1. That means I would need to pass mm, return 1. Okay. This would return me all the possible solutions if I go down, and this would get me all the possible solutions if I go right. Okay. At the end, D plus now we also need to add a DP check. DP check if DP of I comma j not equals to -1, and I will pass return DP of I comma j. Else I am assigning it here. Okay. Let's check now. Storing return 0. What is wrong here? Void O. Okay. Yeah. So I would now need to pass change the function signature. It is initially void, might be print. If I'm returning in all cases, I can remove this. Okay. And we should be good. Let's check. Oh my god. Mm, okay. Instead of the instantiation of template class, here we are facing some issue. Vector of range, vector of int, pp. Okay. Vector of oh, not in command. It should be vector of vector. Okay. Now it should be good. Let's check one more time. Okay. Now let's try and submit. Hooray! We solved. And if you can see, we The time runtime is almost 0 milliseconds, and we get 100% of the submissions. Hey,